It's okay. I'm going to start right now. For all of you that are just jumping into this video, welcome to 1-5. Okay, so adjacent angles. If you look at the picture, they have to have a common side. So the common side of these two angles will be this, right? You guys good? Yeah?
I'm sorry with the notes.
Okay. You're good though? You got them?
I just got them.
Okay. So their common side would be ray CB, right? Their common vertex would be point B, and then no common interior point. So nothing here the same as over here, right? Nothing else is shared about the two angles. So we would say angle ABC and angle CBD are adjacent. Okay? Any questions on what would make adjacent angles? All right, second one. These are my favorite ones. I don't know why. They just are vertical angles. And it's not like straight up and down, not that kind of vertical, okay? Vertical angles, the definition says it's two angles whose sides are opposite rays. I usually just say it's two angles that share a vertex and they're like across from each other. So if I were to draw a picture like this, okay, yes, their rays are opposite angles, right? These are opposite angles, and these are opposite angles. Opposite rays, not angles. But the vertical angles here, if I call this angle 1, angle 2, angle 3, and angle 4, the vertical angles are the ones that are across from each other in the picture. So for instance, in this picture, it would be angle 1 and angle 3. Okay, or angle 2 and angle 4. Okay, so they kind of mirror each other, I guess you could say. They're across the way from each other. Those are vertical angles. We'll talk about this later, but vertical angles are always congruent. So 1 and 3 are the same measure, and 2 and 4 are the same measure. You don't need to write that down right now. I will talk to you about it later. Any questions on vertical angles? Okay, complementary and supplementary you've heard before, right?
Yeah.
You should have, depending on where you've been to school, what math you've taken, but you should have heard of it at this point. What's the difference?
Complementary is 90 degrees.
Complementary is 90, supplementary is 180. Here's how I tell people to remember that. If you think of the alphabet, C comes before S, right? Complementary comes before supplementary. If you go numerically, 90 comes before 180. So complementary is the smaller one, supplementary is the bigger one, okay? Complementary is 90, supplementary is 180. So the definition is two angles whose measure have a sum of 90. Okay, so they're gonna add up to 90 degrees. It's two angles, not 3, not 5, not 1, two angles whose sum is 90 degrees. So there's options here for what this could look like. It could be that your angle looks like this. Okay, they'll put the little box here to show it's 90 degrees. And we would say angle 1 and angle 2 are complementary. They add up to 90. But now 1 and 2 are also adjacent, right? They're touching each other. They share a ray, they share a vertex. They don't have to be adjacent to be complementary. So I could say that this angle here, which is 40 degrees, we're just guesstimating, and this angle here, which is 50 degrees, right? Those two angles are still complementary because I can take those two angles, add them together, and they're 90. Okay, so they can either be adjacent or not adjacent, but they're still complementary. The same is true of supplementary. And supplementary is a little easier to see because you can see when something is a straight line, right? So supplementary, if I have two angles that add up to 180 instead, they're gonna make a straight line. So we would say angle 1 and angle 2 are supplementary. Okay, but again, they don't have to touch each other. So if I were to give you a 120 degree angle here, and a 60-degree angle here, okay, those two angles are still supplementary. They add up to 180 degrees, okay? Two angles, 180. Any questions on any of that? Okay, so let's look at this first example then, using all those terms that we know. The question first is, are BFD, angle BFD, and angle CFD adjacent? So look at where BFD is, BFD, right? And then CFD, CFD. Are those adjacent? Let's walk through the list. Do they share a vertex? Yes, they both share F. Do they share a ray anywhere? They do, FD. Do they have common interior points? Yes, that's a problem. We can't have that, right? So these are actually not adjacent because they have overlapping points. We'll say because. Sorry, I should have gotten my highlighter away and gotten out a pen, but those are not considered adjacent. Yes, they share a ray. Yes, they share a vertex, but they also share all of this stuff, right? That portion of the angle is in both of our angles, and they cannot share like that, okay? Okay, I'm gonna delete all that, erase all that, so I can scribble again. This next one says, are AFB, okay, so there's AFB, and EFD. Are those vertical angles? Who thinks yes, those are vertical angles? Who thinks no, those are not vertical angles? I see like a handful of opinions. Everyone else is not sure. The answer is no, okay? Remember, by definition, vertical angles have opposite rays. And if you think about that, this FB, the opposite ray for that would have to go through here, and it doesn't. So this would be no, they're not vertical angles because they're not opposite rays. Okay. All right, last one of these. Let's erase again. Now it says, are AFE, so here's AFE, A to F to E, right? That's that angle. And BFC. BFC is right there. So are the pink angle and the purple angle complementary? What do you think? $62 and 28, is that complementary? Yes. If you take 62 plus 28, you get 90. So we would say yes, they are complementary. Okay. Any questions on that? Okay. Then the next thing, there are a few things that you can conclude without any markings given to you, okay? Most things, we don't want to assume, right? Everyone knows what happens when you assume. No? Nothing? It's a bad word. We won't say it. Anyway, don't assume things, okay? Assumptions lead to errors, and that's never a good thing. So without having to assume, there's some things that you can conclude even if they're not marked for you. So like normally we would look at an angle and we don't want to just say, oh, that's 90 degrees if it's not marked as 90 degrees. We can't assume that. But we are allowed to say angles are adjacent even if they don't tell us or mark for us that they're adjacent. So for instance, if I had this, I could say, just looking at it, I can tell that angle 1 and angle 2 are adjacent. Okay, there's no need for markings to show they're adjacent. So that is allowed to be assumed. Second thing, you are allowed to say that we know when angles are adjacent and supplementary. What do adjacent supplementary angles look like? Do you know? Supplementary means 180, right? So you're going to have a straight line, which is why you're allowed to say that they're adjacent and supplementary. You could say that those two angles right there are adjacent and supplementary angles, right? Because we can see that it's a straight line and we can see that they're adjacent, we know that that's true. Okay? The other thing that you're allowed to conclude without having any markings whatsoever is vertical angles. If I have a line here and a line here, and I have angle 1, angle 2, angle 3, and angle 4, they don't have to mark anything for me, and I can say, I know that angle 1 and angle 3, are vertical. Okay, or I know that angle 2 and angle 4 are vertical angles. Does that make sense? So most of the time you have to have markings. They have to say these angles are congruent or these angles are X number of degrees. These three scenarios are the only times you don't have to have markings for it. So thinking of those three things, look at this picture and tell me what you know. 3 and 5 are vertical. Okay, so we know that angle 3 and angle 5 are vertical angles. No one told us, right? We just can look at it and see that those are vertical angles. What else do you know? Do you see any adjacent angles? Yeah, John.
3 and 4 adjacent.
3 and 4 are adjacent. Julia, what else is adjacent?
4 and 5.
4 and 5 are adjacent. There's also adjacent supplementary. Yes, so we can say angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4. See the pattern? Angle 4 and angle 5, and angle 1 and angle 5. Those are all adjacent, right? But we also know adjacent supplementary. Which ones are adjacent supplementary? Angle 3 and angle 4 are adjacent supplementary angles. Okay, what other ones are adjacent supplementary? 4 and 5, right? As long as they make a straight line and it's those two angles, we know that to be true. Is there anything else you know that's true in this picture? What are the markings in this picture telling us? 1 and 2 are the same. Yes, you also know in this picture that angle 1 is congruent to angle 2. Okay, so markings given, you're allowed to say that's true. But if there's no markings, these are the only things that you can say are true. Okay? All right. Next thing. A linear pair is exactly what it sounds like. It is a pair of angles that are in a line. Okay? You're going to see a lot of linear pairs in geometry in general. So the definition, it's a pair of adjacent, meaning angles next to each other. Okay, a pair of adjacent angles whose non-common sides are opposite rays. Now that's just a fancy way of saying two angles that are next to each other that form a straight line, right? This is going to be a straight line. You have these two angles that form that straight line. So that would be considered a linear pair. Angle 1 and angle 2 are a linear pair. Okay. What is true of two angles that form a linear pair? We've kind of talked about it already. They're supplementary. Yeah. When two angles form a linear pair, they are going to add up to 180. So two angles that form a linear pair are supplementary. Okay. Any questions so far? I know that's a lot of terms. We're done with terms. Now we're going to actually solve a problem. I lied. We're not done with terms. There's one more right here. But then we're done with terms. Okay, so with this, look at what we have. This should be familiar to you because this we've done with segment addition postulate, that type of thing. We even did it with the angle addition postulate yesterday. So it says angle KPL. KPL, that's this one right here, right? And angle JPL, that's this one, are a linear pair. So what do you know about those two angles? They're a linear pair. That means they're, John? They're what?
They're adjacent.
They're adjacent supplementary. So they're going to add up to 180, right? People are always like, they didn't tell me how much their total is. They don't have to. If it's a straight line, it's 180 every time, right? So if we know that and we know their expressions and they ask us to find the measures of the angles, we're just going to take them, add them together, 2x plus 24 plus 4x plus 36, and set that equal to 180. And now we can do the algebra. Hi, Michael. So from here, we're going to do 2x plus 4x is 6x. 24 plus 36 is 60 equals 180. Okay, now we take away the 60 and we get 6x equals 120. And then we divide by 6. So x is 120 divided by 6 is 20. Okay? They didn't ask us for x, but you need to find x to get what they did ask us for. So the next part, if x is 20, we're just going to plug that in right here and right here, and we get our two angles. Okay? So the measure of angle KPL, KPL is this one. So we're going to go 2 times 20 plus 24. That means KPL, actually we'll just go here. So that's 40 plus 24 or 64 degrees. Can anyone tell me what the other one should be right now? 116, right? If it's going to work out, it should come out to 116. Let's check it. It's got to add up to 180. So angle JPL should be 4 times 20 plus 36. So that's 80 plus 36. Wouldn't you know it? It did work out. Okay, so those are your two angle measures. They add up to 180, so we know we're right. And we move on. Any questions on that? Okay, last thing is an angle bisector. We talked about a segment bisector before. Do you remember what a bisector does? What's a bisector? Do you have it, Abby? Cuts it in half. Yeah, so you're going to have two equal parts, okay? So an angle bisector is cutting this big angle in half, meaning these two parts are congruent, right? Which you have the little markings there. So it's a ray that divides an angle into two congruent angles, okay? A ray that divides an angle into two congruent angles. So if you look at example 4 here, it says AC bisects angle DAB. So this DAB is getting cut into equal parts here and here. If DAC is 58, what is DAB? Notice DAB is the big angle. What's that going to be? What? I didn't hear. 116 again. It's a popular number right now. You have 58 here, which means you also have 58 here. So you're just doing 58 plus 58 is 116 degrees for the measure of angle DAB. Okay. Now, sometimes they're not just going to give you straight numbers like that. Sometimes they're going to give you expressions instead. So it's going to be like 2x plus 4. Let me give you a for instance. This is not drawn to scale. You don't even need to write this. But let's say I told you that this is a bisector, and this was 4x plus 2, and this was 3x plus 12. What do you do in that scenario if that's a bisector? You set them equal, right? If it's a bisector, they're equal parts. This is not at all drawn to scale, so you don't need to work this out. I just want you to see the setup of it, okay? Maybe it is drawn to scale. Let's see. 10, 30, 42. That's not terrible, you guys. It's close.
You can do geometry so long as just.
I guess it's like osmosis. It just happens. Any questions on that?